Great. Thank you. So the next session's title is on interactive VR environments using computer vision tools and technologies. Of course, the immersive virtual reality technology depends on the base on computer vision. The session speaker is Dr. Ratnakar Dash. So let me introduce this session speaker, Professor Dr. Ratnakar Dash. Dr. Dash is an accomplished academic and researcher in the field of computer science. Dr. Dash has been serving as an associate professor in the CSE department since 2011 at NIT Rourkela. He holds a BTech degree and MTech and earned his PhD from NIT Rourkela in 2012. With over 50 research papers published in reputed international journals, Sir Dr. Dash has also successfully guided 6 PhD scholars. He is currently leading a government-funded project on early detection of breast cancer using advanced deep learning techniques supported by the Department of Health Research, Government of India. Dr. Dash is an active member of prestigious professional societies such as IEEE, IE, ACM, and CSI. His primary areas of interest includes machine learning, deep learning, computer vision, and image processing. Sir, we are privileged to have you to share your insights and expertise with us today, specifically on computer vision tools and techniques, how that it could support for a virtual reality environment. We understood that this computer vision tools or computer vision is the base to create on images for the virtual reality technology. Hope your session, your expertise will enrich our knowledge towards attaining the objective of this FDP. Now I leave this meet to Dr. Ratnakar Dash. Thank you, sir.
Am I audible?
Yes, sir.
So good evening, everyone. So many thanks to the organizers who have given me opportunity to speak on this. Okay. My area of specialization is computer vision. Now we have also started working computer vision applications in AR and VR. Some of the students are also working in that direction. As we know that nowadays this is one of the key technologies being used for many of the applications. So I'll be confining my talk on what are the different tools and how computer vision is helpful for developing a VR environment, and what are the tools people are using, what are the research challenges, what are the limitations, and in what way we can contribute using computer vision to the development of AR and VR application. So let me just switch off my video and share the screen so that there will not be any issue with the networks. I'm presenting my screen, the entire screen. So is the screen visible? Slides are visible?
Yes, Professor.
Okay, fine. So the topic of today is interactive virtual reality environment, computer vision tools and technologies. So do we know that virtual reality is a kind of technique where it gives a simulated experience to the users of the VR in a completely virtual environment where the users immerse themselves and try to manipulate objects and can do various kinds of things using some hardware as well as software. So the hardwares and softwares we will discuss what are the hardwares and softwares required for making a user to be immersed in this VR environment. So there are different kinds of VR environments. One is completely immersive, which gives a vast experience and requires knowledge of computer vision. And there are also techniques like in VR, there are semi-immersive and there are some flight simulations we can call that as a semi-immersive. And if we are trying to visualize a particular object in 3D, we can call that as a non-immersive as well, where the user do not have any feeling in a VR environment. So in VR technology, as we know that this, to start with, let us see what is a computer vision is. As we know that computer vision is a field of AI, artificial intelligence, which enables the machines to take visual data and analyze the visual data and use it the data for particular applications. So in applications to VR, we can have multiple things in computer vision which are mostly used for VR development. One of them is object detection, where we try to recognize and interact with the virtual objects. Okay. Now, the gesture recognition, I've highlighted it to emphasize more on this because this is one of the important tasks which helps the computer vision uh, researchers to use this particular technology for tracking hand and finger movements and can give some instructions in the VR environment, which has been very popular nowadays for integrating the gesture in the VR environment. Another one could be eye tracking, where we try to understand the environment, where how the user is looking in which direction it is moving, and we can track the movements of the eye. And through also a scene understanding, where real-time comprehension of the environment to increase the user interaction. Now, as you know, there are many benefits of combining this VR technology with computer vision. Computer vision was previously available. It was it's not a new technique. We are using this computer vision for many applications in the old days as well. Now we try to use this for developing VR environment. So what is the benefit of combining or integrating computer vision in VR? One of them, some of them has been listed here. One is the enhanced realism, where we can feel like a real-time recognition and adaptation, so that user feels that I am being immersed in a particular environment, a simulated environment, and we can have a interaction with the different objects, and using controls like gaze and gestures, which can also eliminate the need of complex input devices. So initially, when VRism started, so the people are using some input devices to control all those things. Like nowadays, we use this gauge and gestures to have the control of for different interaction, which like gives like a natural feeling of interacting with the real world objects. Okay. Then in dynamic environment, we also have adaptive environments which responds to user actions and preferences in real time. So all we know that there are many vast applications of combinations of VR, which uses computer vision, so starting from gaming to healthcare, and we can also combine all these applications to see what are the new things that can be developed with the integration of virtual reality with computer vision. So as I told, one of the important tasks is object detection, where the users try to identify or localize the objects in a real world scene. It feels like I am in a particular simulated environment, and I'm trying to interact with different objects that are present in that environment, and it gives a feeling that I am completely immersed in that. So it enables users to interact with the object naturally and allows the environment to respond dynamically based on the detect objects. As the time passes, I'll show some videos where you can see that how the computer vision technology has already been used by many of the cases where people try to use different objects, and using this object detection and uh, dynamically controlling the objects for various tasks. So for object detection, as we know, the conventional now techniques of machine learning, that is YOLO. YOLO is a very popular object detection technology. This is also being primarily used for in a VR environment. We also have single shot detector, which is very fast and lightweight also. So these are the techniques we generally use for object detection to create VR environment. So these are the computer vision techniques where we try to detect the objects of different resolutions using different thresholds. So yellow is very popular, and there are different versions of yellow also exist. And currently we are using yellow V8, which is a very popular one and can detect the objects by addressing various challenges. So I'm not going deeply on that. These are the techniques that we mostly use for VR environment for object detection. Okay. Then what is the why this interactivity is important? Because as you know that interaction, the more interaction, more the feeling of engagement in the VR environment. So it can influence the virtual world through gestures, actions, and command, and enhances engagement. Users feel very immersed and they feel that very interactive in the environment. It can also boost the learning capability. Let's suppose VR is used in education, so people think the who are immersed in VR environment can boost their learning and the interaction. As we know that as the interaction improves, understanding also improves. It also can have a two-way interaction, not only single-way interaction. So it also increases realism when we interact with some particular object or some particular data inside the that are present in the virtual environment. It gives us a feeling and which can also mimic the real world responses, so which also deep our immersing power. Now coming to one of them, was I told, that's object detection. Next task what we basically work currently are the hand gesture recognition for interaction. So hand gesture, people use their hands for providing gestures and instructions. So there are different types of gesture recognition techniques are being followed, and where to interpret the hand gesture to control with the VR. So one of the technique used for gesture recognition is convolutional neural network. Also, how we have also developed a CNN model for recognizing various gestures from a dynamic gesture, static gesture, and apart from CNN, there are also tools like Media Pipe and teachable machines are also been developed, or frameworks and also been developed by Google for different types of computer vision tasks which are primarily used for in the VR environment. So applications are, as I know that the same applications controlling the virtual objects without physical control, intuitive managed navigation in VR. So one of them example is sign language recognition system using VR. Another one is the quest hand tracking for object manipulation. Then type of gestures, as I told, gestures are being primarily used for controlling the objects. One can be static one, another could be dynamic. So static gestures refers to recognizing the still images or frames, like somebody tells to stop, to start, okay, and showing the digits 1, 2, 3, 4, and so on. So there are for different application. So we can call those as static gestures. So using the static gesture also we can communicate with the real world in the VR environment. So more realistic would be the dynamic one, which are used for very crucial applications like military applications, healthcare applications, where we provide complex gesture through computer vision technique, and they are captured through motion tracking, and there are many tools have been developed to track those motions of the gestures or motions of the hand, motion of your face, facial expression. So many different types of complex gesture are being used for dynamic gestures, which like for example here it is given drawing a shape in the air, waving your hands, and for and providing gesture for particular instruction. So this is the framework for hand gesture recognition. We capture the input using cameras or sensors to detect hand movements. So this hand movements is a very is a common example. Without hand movements, we also can provide gestures using your head and other body parts. Then once we capture the, like as I told, we are using computer vision techniques. So cameras and sensors are being primarily used to detect the hand movement, or also we can have some gloves like thing which are being embedded, which are being placed on the hands, and which has the sensors which can provide the gesture also can be read from that using some camera or sensor. Then hand tracking and segmentation. So this is very, very important. How to track the hand, and once, so this is mostly required for a dynamic gesture, because tracking is not required in your static gesture. So once we are waving hand, let us suppose if you are waving hand for a particular, providing a particular gesture, so we need to segment the hand from the whole background. So that is very, very important. We need to track the hand and where, from which point to which point it is moving, followed by the feature extraction. So actually they are connected, not shown in the block diagram, however they are connected step by step. First is acquisition, followed by hand tracking and segmentation, followed by feature extraction, followed by gesture classification. So this feature extraction is a very crucial step in learning. So whatever the case, VR environment or gesture recognition you do, this is the one of the most crucial step in all kind of learning tasks. So computer vision tasks related to integrated with VR requires feature extraction. So once features which represent the unique characteristic of a particular object, like for object detection or detecting the gesture or classifying the gesture, all requires this feature extraction step. So once features or unique characteristics of the particular input is obtained, we follow this is followed by classification. So once they are classified, they are converted to either text or voice to do a particular task. So for classification, we generally use some CNN models. Feature extraction as well, we do some CNN models. So this is an example of gesture recognition system or gesture recognition, where we have, I'll show you some one of the CNN architecture what we have created for detecting American Sign Language. So this is a gesture visual data collection consisting of videos or images capturing hand gestures and signs used in American Sign Language communication. So this is a very popular data, ASL data, we can call it ASL data, sign language, primarily used for enabling communication between different dumb people, and they can use this sign language to communicate with the outside world. So for this American Sign Language 26, as we know that there are English alphabets are being used, and from numbers 0 to 9 are in the data set. So we have created a CNN, conventional neural network, to recognize this. So further we are trying to create a VR environment to integrate this ASL framework onto the system. So for this particular task, we have taken this ASL dataset consisting of letter A to Z and numbers 0 to 9 in real time. We have also created our own gesture dataset for sign language. So why ASL in VR? As I've already told you, this gesture recognition is one of the important part in VR. So ASL comes in that. ASL is a gesture recognition system. So it facilitates natural, the same region being written here, facilitates natural and intuitive communication for deaf and mute individuals in virtual environments. So they can uh, overcome or this address the limitation of their physical and geographical barriers for effective communication. So basically, this sign language is a very recognition is a very useful recognition system, which helps this particular enable persons for their effective communication. They also provide, if they are integrated in the virtual environment, it also provides an immersive platform like normal people, how they communicate in the VR environment. The deaf and mute people also can get a immersive experience in the for learning and practicing the ASL in VR. Now coming to the tools for use for tracking and segmenting, these are the common tools, very popular tools used, developed by Google. One is the Teachable Machine, another one is the MediaPi. So Teachable Machine is a web-based tool. It is developed by Google. It allows user uh, to train the machine learning models without knowing the details of it. Like, it's teachable means it trains a model using images there are hidden layers to train a model like conventional machine learning models. But somebody, suppose we do not, somebody don't know how to write a code for a particular machine learning algorithm, so it can easily use this teachable machine to develop a machine learning model for creating for classification or for any task. So the features are no code is required. We can build our models without writing code, which is simply need to drag and drop. And it also facilitates to take input as images as well as videos, and also it also can capable of combining the images and videos in a to give the input to the teachable machine. Okay, it also can be deployed in real for real-time application and suitable for very diverse applications for like gesture recognition. So we also, apart from CNN, we also have used this teachable machine and to see or to investigate how this performs for this ASL dataset. So the data set collected with the help of webcam is uploaded here, and then after, so we use this our own data set, self-constructed data set, and use the teachable machine how it works to see that or to compare with the CNN, the recognition of power of recognition of CNN along with the teachable machine. Similarly, MediaPipe is also a open source framework also been developed by Google for building this real-time machine learning algorithm. So the applications like teachable machine can be used for any machine learning applications. Our MediaPy mostly used for hand tracking and face detection, pose detection, object detection. So this is a very common tool developed by Google and open source tool, which helps users to use this particular tool for hand tracking, pose estimation, object detection, and it provides a ready to use solution with optimized performance. It can be used in various platforms. It's very open, and it can very easy to use this media pipe and teachable machine. So mostly this media pipe uses a graph based architecture for giving a good solution. So you can see that this the fingers the for different letters in the hand are being detected, and the counters have been plot using this teachable machine and media pipe. Image captured with the help of webcam reprocessing. First, as I told, there are various steps for ASL detection. So these are the steps I have shown here to what we have used for using a customized CNN layer. So we have used a customized CNN layer along with teachable machine and media pipe to show how it performs and in comparison with the CNN architecture, our own developed architecture, and with the Google-based developed tool. So for the pre-processing, data resizing, normalization, noise reduction, all try to standardize and enhance the quality of the input images. And standardizing the input images is crucial for consistent and reliable model performance. Followed by pre-processing, we use CNN. As I told, CNN is being primarily used for feature extraction, which learns and extracts relevant features from the detected hand region to facilitate sign language gesture. For real-time implementation, we shape this model in the PyCharm environment to detect hand sign in real time using OpenCV or MediaPipe. So for once we detect the gesture for real time, we use this OpenCV tool and MediaPipe to deploy it in the real time. This is the architecture that is being developed by one of our research student to for gesture recognition. This proposed customized. So this particular architecture has been customized looking into the different gestures. This is mostly for the American Sign Language, where we have used one data set openly available. You can see the architecture. There are four convolution layers, convolution 1, 2, 3, 4, with followed by four max pooling layers, and finally being added by a flatten layer and softmax layer for to detect the 26 hand signs. Okay, using a 26 set of neurons in the output layer with a stride. So different variations of this particular architecture has been studied or investigated, and we fine tune the model for different inputs. And after fine tuning or hyper, there are so many tunings have been out optimized. Optimization has been applied to create this such a this customized model. And also so with this our customized model, you can see that with real-time outputs after deploying using the CNN, you can see that how we're able to see the gestures with different sign languages output of ASL, sign of letters from A to F. You can see that we are able to detect very easily using this CNN concept. So this particular technology can be very easily integrated using the concept of this Unity and real-time engine, which are being developed already been developed to create virtual environments. So the important task here is to how to detect the gesture in real time with different backgrounds and with the existing environmental conditions which are diverse in nature, and which for real time implementation it poses a very much challenge. So these are the results for using media pipe. As I told, media pipe and teachable machine also does the same task. To have a comparison, we show the outputs of ASL hands. That what I mean to say is that we can develop a machine learning model to detect all this. However, there are also tools, computer vision tools available, which can directly take your image or gesture or pose, whatever. So it can you can train the model using media pipe and teachable machine. Like you can track the hands and segment your background, and using these tools, and can directly just drag and drop the machine learning models using teachable machine and create a recognition system. So that you don't have to worry much about the how to track the hands, how to separate the hand from the background. All these tasks are already being handled. And however, there are some limitations of these particular developed tools, where people are researching on it, how to develop or how to address these limitations with which can be used for diverse applications, like for speech classification, object detection, and using this in for VRML, because integrating directly into VRML poses so many challenges. So for that, we need to worry about how the gestures are detected and whether they are detected correctly or not, and provides a good accuracy or not. This is another example which uses a convexity or convex Hall approach. So for digit recognition for 1 to 5, you can see that same ASL hand sign data set using convexity approach. So convex Hall already tools have been already there. We try to use that tool to develop the recognition for different digits. This is one of my scholar who is working on this and have developed this recognition system using CNN convexity approach, using teachable machine and media pipe, and done a comparison. And this is the what I've already shown, the model development for CNN architecture. You can see that there are total number of parameters are very huge. Trainable parameters are something is like 1,31,421. So you can see the how we are able to use this the huge trainable parameters, because these are very important for customization. Once you try to customize any model, we need to see what are the different parameters, what are the hyperparameters, how they can be tuned, how can they can be optimized. So instead of going directly for the tools that have been developed by Google, we need to understand how they work and how we can modify the architecture, how we can develop our own architecture. So the research team is our research team is already engaged in doing that investigation. So in the initial preliminary phase, we have developed this CNN architecture. So this is the tabular result for classifying the gestures. After testing, you can see that for letter for the different classes, 26 classes of the letters. 0 class represents Y, 26 class represents Z. You can see there are various parameters like precision, recall, F1 score, support. So they also have been extracted, and you can see that it provides a very good accuracy on this ASL dataset, because this ASL dataset is a very standard dataset and have been developed and being used by many researchers for doing multiple tasks. So on that side, the result is quite good. So it's not always possible that we will get a good result for all kinds of sign language datasets. As we know that the sign language dataset is very different, diverse in different countries. And if we see in India, if we try to develop a sign language system, so this is different with respect to the different languages. We speak in different parts of the India. So somebody tries to develop a sign language system and try to develop a recognition system for that. So it's a very big challenge. And apart from that, using these sign languages and using this in a VR development or VR environment is again a challenging task. So these are the some more results of regarding epochs and loss accuracies. So this is nothing to do with the VR, is simply the experimental set of results. You can see that here the tabular results and with the comparison with the media pipe and teachable machine convexity approach. So here media pipe we used to uh, track and segment the hand out of the whole scene, and teachable machine is the learning algorithm we try to use. So we can see that we are able to manage the design the CNN model, the proposed CNN model, it at par with the, and rather it gives better accuracy than the already developed tools. So because these tools are it's not customized for a particular data, particular application. So this our proposed CNN model will try to customize with respect to the particular data. That's why the results are better as compared to the media pipe and teachable machine. So though this the tracking of hand and the segmenting the hand from was a difficult task for us from the data, because this data is with respect to the ASL framework, ASL data, so which is a very standard data. If we try to use the same proposed CNN model for other data, it may not perform well, because there are a lot of tasks, pre-processing tasks and hand tracking and extracting the fingers, extracting the and tracking the movement of the fingers and segmenting the hand from the scene, which are very crucial to obtain a good result in gesture recognition. So this if for those tasks we can go for media pipe and try to use teachable machines for learning. However, it is always designed use these tools for the pre-processing and try to design your own customized CNN model and own LSTM or whatever model we try to design deep learning based models for providing a good accuracy, because that depends on the what kind of data we use. So you can see that complexity approach is not giving good result at par with the proposed model, media pipe and teachable machine as well. So these are the accuracy, precision, and F1 measure, which comes around 99. This is the summary model summary, which we try to propose this model to help deaf and hard of hearing people to communicate with others. As I told, the sign language system is basically made for those kind of people for a effective communication. And in the media pipe also achieves a good accuracy. So we use rectified value. So I'm not going to detail that what are the different activation functions, what are the pooling techniques we use in the CNN, which are also plays a crucial role in designing a CNN model. So as a part of future work, we can pursue to refine this methodology and try to use a CNN which can be more generalized to such size recognition tasks. Now coming to more tools and techniques of computer vision, we we use this, as I told, eye tracking is also one of the important tasks in VR environment. So detecting where the user is looking to optimize focus for interaction. So it improves rendering efficiency while the video is rendered. So it is formatted for high resolution gauge area. It requires good eye tracking technique. So we can use infrared cameras for precise gaze detection and machine learning algorithms to predict the gaze point. So finally, what we see here, that these tools are combined with the machine learning algorithm. So when we try to develop a particular application in any VR environment, so like here we require to track the eye and predict the gaze points. So we must have to use a machine learning algorithm. So in this way, the what I mean to say is that whatever tools and techniques of computer vision are used, finally we need to use a learning algorithm to interact or integrate our task for VR. We must have to see what are the different algorithms and try to develop our own algorithms with respect to the application to be developed. So this is a HTC Vivo Pro I for foveated rendering. So this is a gaze control menus in VR environment. And then coming to the, as I told, VR is giving us the users immersive experience in a simulated environment. So for which we can use different hardware and software. So hardware is like somebody uses as we know, all know that different gaming platforms and different gaming zones use these VR headsets. So they can be different types of, there can be different types of headsets which the user has to use these particular headsets to feel that I am in a virtual environment. So we can have standalone headsets which do not require external device and operations like Pico, Neo, and Oculus Quest. So these are all headsets available. We can have PC-based headsets as well, which depend on a powerful PC for processing like HTC Vive Valve Index. We can also have console-based headsets which work with gaming consoles like PlayStation VR. So these are already developed different headsets and which user has to use for to have a feeling in the virtual environment. The components, as I told, hardware components as well as software components. So hardware component headsets. So these headsets, as I know, told that provides a visual interface. There are also controllers along with the headsets, which allows users to control with the virtual objects and environments. So like Oculus does, Valve Index controllers also have, we must have sensors to track the user movements and gestures. So in this particular hardware, using this particular hardware and the integrated software, we can create a virtual environment and have a feeling of virtual reality. So this is the Oculus Quest, picture of the Oculus Quest, which has been taken from Amazon. uh, it have headsets, controllers as well as sensors. Now, hardware is important as well as software is important. So there are different software frameworks. So as I told that for gesture recognition and machine learning framework, we use teachable machine and media pipe. Similarly, there are also software frameworks like Unity and Unreal Engine. So Unity and Unreal Engine, these are two popular game engines, and these are two platforms, okay, used for creating a 3D experience, interactive experience in the VR environment. So like they are also used for AR. Like features are cross. Unity is a VR game development engine. So which can be used in different platforms, and it can also use for AR VR toolkit, and it can be easily prototyped. So this both these platforms provides unique features like strength and workflows, so that can cater the needs of the particular requirement. Uh, Similarly, Unreal Engine is another software framework. So, like suppose we want to, like we have developed this gesture frame or a recognition model for detecting the gesture. Then, for integrating those gesture on object detection software, we need to use this software frameworks. So like Unity and Unreal Engine. So Unreal Engine is also similar to the Unity. It is also known for high quality graphics, and it is developed by some company known as Epic Games, and having high quality graphics and realistic. This mostly provide for rendering, advanced rendering. So features are blueprint scripting, advanced rendering. So if you compare this Unity 3 and Unreal, so depending on the requirement, we can go for Unity. These are completely open source environments. So they are written in have the AR VR support and having cross platform support, and scripting is mostly written in C or Python. Uh, if you compare, so it is Unity is like beginner friendly and having wide community support, and Unreal Engine is preferred for photorealistic application. So link for the, let me just see what it is providing. We have a example or video for,
Navigating the Unity editor interface is easy.
this is a
The core
Unity
of the
engine.
interface consists of 5 main panels: the scene view, the hierarchy, the game view, the project panel, and the inspector panel. The scene view is where you'll visually construct your game.
So this is a framework. One we
Manipulating objects in 2D
we need to
and
understand
3D.
this. Once we work with the tool, we can understand that
The game view
all
is where you
manuals are
preview
being
your game,
present. So
and this becomes
we'll
active when you hit the play button,
stop here. I'll
allowing you to
provide this link to you so that you can follow this later. Uh, Now another techniques of computer vision used mostly in VR is, one of them is I told gesture, another one is object detection, another one is depth estimation, which are very important for creating a interactive 3D environment. So measuring the distance, for suppose we want to create a 3D environment, we require the depth to be estimated. So depth between different objects, distance between the objects in the same scene. So stereo vision techniques can be used for that. So where we use two cameras to mimic the human eyes to calculate the depth. And we can also use time of flight sensors, which emit light pulses and measure the in return time. From the return time, we can measure the depth, how much distance it is. And structure from the motion, we can estimate the depth. So there are different depth estimation techniques used. Those are computer vision techniques only. So which can be used to create the create a 3D modeling in the VR environment. And applications are ensuring realistic object placement, because the objects are 3D in nature, so we can have accurate motion tracking in 3D space. So examples are mostly, these are mostly this technique is mostly used for VR games for depth perception. Face tracking and expression mapping. So analyzing facial expression to create realistic avatars. So there are, you might have heard about the avatar or interactions in VR. So there is a real time, like it gives a real time feeling of somebody is moving in a virtual environment, having a creating avatar of someone. So which tries to analyze facial expressions. So those analyzing facial expression, we must have to have an algorithm to be developed and to be integrated in VR. Again, you can see the techniques here: 3D facial mask landmark detection and deep learning for emotion recognition. So how to analyze the facial expression? Again, we must have to have a recognition system for detecting the emotion from the face. So we can use the deep learning techniques for recognizing emotion from the face. So basically, what happens once we try to use this facial face tracking and expression mapping, we have to use this deep learning. For initially, we need to develop a particular algorithm using deep learning or machine learning, using this computer vision technique to detect the emotion. Once they are developed, we can integrate that in the VR environment with some other components of the VR, which can use this facial landmark detection, one algorithm for facial landmark detection, another algorithm for recognition. So that if you are using these techniques in the VR environment, we can use this for particular application for personalized VR experience. So virtual avatars mimicking user expressions. So you can know that there are different avatars are also being created in VR environment to mimic the user expression. One of the case example is real-time object manipulation in VR. So as I already told, VR application which uses manipulate objects in real time using hand gestures and object detection. So the main motive behind this is to use a gesture recognition, hand gesture recognition to manipulate the object and to detect the object. So object detection algorithm using LO, hand gesture algorithm using deep learning can be combined together, and they all can be integrated with the VR application using Unity 3, Media 5, real-time engine, so that we can have a application where somebody can move in the or immerse itself in himself or herself in the environment and can manipulate object depending on the requirement. So they told hand tracking for interaction, depth estimation for accurate placement. So these algorithms are integrated for the VR. So that's the example for manipulating object in VR. So outcome is natural experience, user experience. So I think there is another video shown here. So for real-time object detection, so pick and place, you can see that. So this, like somebody feels that I'm keeping the object and picking it somewhere and placing it somewhere. So you can see that it gives experience that I'm doing that using that hand and providing the gesture how this look like, and you can see that this gives a very good experience to manipulate the objects as and when required, how we check the object, how we manipulate the object, how you keep the, if this person is trying to move the steering, trying to manipulate the objects in the uh, virtual environment. AI personalization in VR experience. So like we can like develop or use, you can use our AI to tailor VR environments and experiences to individual preferences. Like I can develop, I can use the artificial intelligence technology or deep learning technology to, like suppose I want to manipulate a particular object in the VR environment. So I can tailor my VR environment accordingly, and I can use a customized deep learning model which can give a experience to me according to my preferences. Like applications could be personalized training models based on skill levels. We can adapt virtual environments for different applications such as therapy or relaxation, and non-playable characters, the AI-driven non-playable characters that respond dynamically. So these are the different applications where we can use this particular learning, AI, machine learning, and deep learning techniques could be utilized for developing such modules and can be integrated using the already developed tools for the VR environment development. So key techniques could be data-driven algorithms that analyze user behavior patterns, natural NLP algorithm for customized dialogues. So, like for example, therapy, VR apps adjusting environment based on the user stress level. So we can also do a 3D construction in VR worlds. We can rebuild 3D environments using real world data like images, depth maps. Applications are creating realistic VR environment for training and simulation. I'll show you a video where we can try to create a realistic VR environment for training or simulation. So we can use these technologies like structure from motion, photogrammetry, which converts 2D images into 3D models, LiDAR scanning for precise depth maps. So as I told, we require some depth computation and converting the 2D images into 3D models for creating a 3D environment. So you can see that one of the example could historical site construction for virtual tourism. Okay, we can create a historical site for virtual tourism, realistic architectural visualization. So let us see the video.
So behind me we have an amazing experience called the Province House Virtual Reality. We work with the University of Prince Edward Island, the Faculty of Sustainable Design Engineering, to develop the virtual reality experience. Province House Virtual Reality is set to provide visitors with an opportunity to experience Province House during its closure for conservation work. So the full experience is completely immersive. Visitors will put on a headset and have some controllers, and once they get delved into the experience, they get to walk the halls of Province House in virtual reality. So I had a chance to work with 4 exceptional students in the Scene Design Clinic. It was very...
So the essence of these particular videos are that, like, we can also create a VR environment according to our requirement for different applications. The main technology behind this use these computer vision tools and techniques to create our own environment, and using the machine learning models. So this is another example where, sorry. You can see that 3D reconstruction. So this is the part of the video where we are trying to create a 3D reconstruction. Then natural language processing for voice commands. So these are different applications, or these are the things which we can use computer vision for integrating inside the VR. So one is I told the natural language processing for voice commands. So NLP enables voice control interactions, allowing hands-free operation. Applications could be navigation, selecting menus or objects through voice commands, VR assistants interacting with AI-powered virtual guides. So the technologies are like speech-to-text for recognizing commands, AI models like GPT to generate dynamic responses. So voice control navigation in VR games or apps. So once we try to, like I told that, once we try to develop a voice control navigation for VR games, we need to use this NLP, and there are several NLP algorithms available for generating the speech to text to speech, for gesture, as well as for other applications. You can also use the chat GPT like or generative pre-trained models already to generate dynamic responses from the speech, and we can use those speech to control the navigation in VR games or apps, or for any applications. We can create virtual assistants for training simulators. Now this is a haptic feedback system for enhancing immersion. As I told, as we immerse more and more, this gives a real-time feeling to be in the virtual environment. So immersing the degree of immersement in the VR is very important, whether you are completely immersed or fully immersed or partly immersed. So this feedback system is used to enhancing your immersion capability. So it simulates the sense of touch through vibrations or pressure in VR. It uses haptic globes. So it's a globe which simulate the textures and resistance. And there are VR suits which provides full body feedback. So again, we mostly use this for gaming and training applications. So in gaming, simulating recoil and object texture. For training, we require the stitching skills or feedback like surgery. So during surgery, we use these globes to give a completely immersive environment, enabling users to feel virtual objects and to combat the training simulation. So let us see how this is done in the real time. So this is an example where army soldiers train with virtual reality systems.
All the virtual reality stuff, it's just they're additional tools to get you prepped up and enhanced abilities to get you ready for the active duty live fire, the live rounds going down range. So they're pressing on the 240 and the 50 cal. For a heavy weapons company, the 240 being a heavy weapons gun, it's just it's just support by fire for all the line units, all the boots on ground, the infantry companies, and then the 50 cal, obviously a higher caliber weapon. It's just different abilities for our gun systems.
So I started 6 years ago. I signed my contract, got with Dell's company about 5 years ago. And the first year that I was actually in Dell's company, we did have this technology. They've slowly been working on it to try to perfect it to the best of their ability. And it definitely has come a long way in the 5 years that I've been in here.
With the new, all the
Now you can see that how these military training simulations are being created using VR suit without actual testing those in the environment. So these are very popular nowadays for many applications such as military and health, where people the users feel very in the environment very interactive and very realistic without going into the real-time environment. They can operate anything, or they can try to work in for any application in the virtual environment itself. So one of the application is the VR therapy and training simulation that I've already shown you. So it's revolutionizing healthcare by providing immersive environments for therapy and medical training. Applications like simulate control environment to help patients face their fears. We can have pain management using VR environment to distract, alleviate pain during medical procedures. So applications in training, it can be medical simulations like surgeons practice complex procedures in a risk-free virtual space. Physical therapy, VR can guide patients through rehabilitation exercises. So all these applications, either in therapy or training, doesn't have to be done in physically. We can have a VR environment. So now you can see that how we are approaching, how we are advancing in the for creating virtual reality environments, which can guide patients for rehabilitation, for therapy, without going physically. And so these are the different VR systems already being used in foreign countries. Pavlov VR used for PTSD therapy or stress relief. Another one is also VR that provides a realistic surgery training simulation for medical professionals. I think this is another video.
yeah, whatever.
You can see that use of VR in the healthcare system. Education. So in education also, it provides an immersive and engaging educational experience by enabling experiential learning. So the benefits are, it depends the understanding through hands-on virtual experience, provide safe environments for experimentation. Like for physical experimentation, we need to come to the actual place for doing the experimentation. So without going for the physical activity, you can also use this VR to have the same feeling and same experience, rather more better experience and safe with the safe environments. Applications are many, as I told. Virtual field trips to historical sites, museums, or space. We can, without going physically to those things, we are able to know the details of those sites, museums, and space. We can have a virtual tour of so many spaces, which is very it's not possible for all of us to do it. And simulations for complex scientific and technical learning. We can have simulations which can be run in simulated or virtual environment to have a technical learning for scientific things. We can have language learning using immersive scenarios. Examples, already developed applications by Google and Labstar. You can see the virtual field trips to historical landmarks and outer space is already being developed by Google. One is the Another one is the VR-based science labs, biology, chemistry, and physics education. So all these techniques or all these tools are already available in the VR environment, which can be used for, which are also being used for various applications. So another LabStar demo video is there. You can see that how these biology related things are being created in the
Labster's
virtual.
biology simulations give students access to a fully equipped $1 million lab that teaches them key biological concepts and techniques through a fun, engaging, and highly immersive learning experience. Students perform experiments, learn with the help of theory pages and quiz questions, and experience immersive 3D simulations that visualize life science down to the molecular level. Virtual labs are not limited by the time, space, or cost constraints of a physical lab, so students can try and retry experiments, safely learn from their mistakes, work with cutting-edge lab equipment, and conduct experiments not usually possible in a face-to-face class. Labster's biology-related simulations cover a vast range of topics and techniques ideal for courses in general and introductory biology, microbiology, genetics, high school biology, and more. Simulations cover everything from the basics of lab safety and experimental design to core shows that students learn twice as much when traditional lectures are supplemented by Labster's virtual labs. For students by highlighting their relevance and real-world application. Gradable quiz questions test the students' knowledge, also based on deep learning approach. Students also have access to a full theory section, which provides them with relevant background information whenever needed. In the Media tab, students can return to view key illustrations, graphs, and data whenever they want. You will have full access to a learning dashboard that provides you with a clear overview of your student scores and progress. Labster, impact.
So this is an example where this, you can see that the training is very easy, and education, the power of education and training can be improved to a larger extent using this immersive learning capability of the VR. So this is the snapshot for that VR-based science labs for biology. Then in the retail direction, we can have virtual try-ons and virtual shopping. As I have told that there are many applications. One of the applications could be in the retail. So it enhances the shopping experience by enabling customers to virtually try on products and or visit online stores in an immersive environment. So applications, there are many applications for shopping, virtual try-ons. On fashion and beauty, we can try on clothes, shoes, and makeup without visiting a store. Virtual mirrors, we can see how products fit or appear on the user's body. So without going physically, we can try the clothes, shoes, makeup without visiting a store. Very good applications in the retail market. Okay, using this VR environment. Then application also can be provided for consumer goods, where shopping malls we can virtually visit the different stores and make our purchases by just clicking. One clicking, we can purchase a particular item, and we can have personalized recommendations where VR systems suggest products based on the user preferences. So these are not the new thing now. There are also VR already VR tools using this computer vision has been developed like this for this retail. It's IKEA Place is a VR environment where customers use this VR to visualize how furniture will look in their homes. L'Oreal is a virtual makeup try-ons using AR and VR technologies. So like this, we can use this VR for many applications: healthcare, education, gaming, therapy, retail, virtual shopping. So you can see that these are this first the two pictures showing virtual shopping with the help of VR sets. So now you can see that one of in the particular um, uh, how this cloth looks like on the particular woman is being created in the virtual scene, uh, and in another video how it looks like and how you can interact with the particular cloth is also can be checked. So this is the source from the Mintra. Any doubt? Now coming to this, after discussing all these applications and the different vision tools, how they can be developed, and what are the already tools developed using this VR environment, and we can always try to know what are the different challenges and limitations for developing these VR spaces. So one of the important challenges is the latency, which, as you know, that it refers to the delay between the user section movement or gesture and VR system response. Like I told that using these VR systems, we are able to interact with the objects in the VR environment, but how much delay is being tolerated, that's very, very important. So that depends on the user recognition or gesture recognition system that has been integrated in the VR environment. So like suppose I have shown you a ASL framework which has been developed using CNN. So if I use a 20 layer, 30 layer, 100 layer CNN for or a complex CNN structure for recognizing the gesture, so it may require a significant amount of time to respond a particular gesture. When I show a particular gesture, it should be, we feel that we expect that this should respond very quickly in the VR environment. But if it doesn't happen, so that means it's a high latency system, high latency recognition system. It may lead to a disorienting and frustrating experience, causing a loss of immersion. Like we try to feel a very good immersive experience in the VR environment, but if the latency is not properly maintained and not properly balanced in the VR development or the recognition system development and development of the computer vision system for integration during in the VR, so it may have a frustrating experience. So impact can be increased latency can lead to motion sickness and reduce user engagement. So it gives a very frustrating experience and makes the user to avoid such kind of engagement in the VR space. It can affect real-time interactions in multiplayer VR applications like gaming type applications. It must be very fast because the responses should be very quick. If the responses are not quick, it's whatever the gaming application you use in the VR environment, it will not work properly, and it will not have a real-time feeling of real-time interaction. Then resolution limits are also there, where VR headsets require high resolution for clear visuals, but current technology often struggles to deliver the level of detail needed for a fully immersive experience. So for a fully immersive experience, we must have to have a very clear picture or very good resolution, which is always remains a challenge for the designers of the VR headsets. And there is always research going on to improve these resolution limits to have a better feeling of the images and objects in the VR environment to have a fully immersive experience. Otherwise, it will look like a partly immersive experience. So the impact could be low resolution can result in screen door effect, where users can see the grid of pixels breaking immersion. The screen, there is a effect, this effect is called screen door effect. Like when you zoom in an image without, if the image is not of good quality and good resolution, it may broken, the pixels may look like broken, and we do not have a good experience to see that particular picture, and we don't want to see those type of pictures. Similar feelings may also happen in the VR environment, like grid of pixels breaking immersion. Reduced image quality impacts the realism and fluidity of the, so it just impacts the reality and fluidity of the VR experience. So always when the user tries to use the VR, we should have a very good experience, and it looks like real, and we should not feel that we are in the virtual environment too. So if this the image quality is not better, it affects the realism and fluidity of the experience. Another one limitation is the computational demands and energy consumption. So high computational requirement of VR systems, especially high-end setups, demand significant processing power for rendering complex 3D environments, tracking motion, handling real-time interactions. Like we know that to have a particular application in VR environment, we require so many things. Like if you compare simply a gesture to be involved in the VR environment, it's starting from the image capturing, followed by pre-processing, followed by feature extraction, followed by identifying the gesture, then the tools of during pre-processing, again the tools like MediaPipe, teachable machines work, and how they are being created to just analyze the complex and intricate patterns in the input uh, for tracking motion and handling real-time interactions. It's very complex in nature, and also the systems which tries to render these complex 3D environments have high computational requirements. So high-end setups, they require a significant amount of processing. So if these high computational requirements are not made properly, so this will have an impact. So it may process demands for increase as VR environment become more detailed and complex. Lettering and stuttering can occur if the systems cannot keep up with the even, like suppose you have developed a system which where the latency is very low. However, if the system which is used to develop the VR environment not of good computational facility, then it may the it may clutter, and it cannot, it may not be synchronized with the recognition system which has been integrated in the VR environment, so which just poses a hindrance in this particular application. So then energy consumption is also an important role. VR headsets, motion controllers, other hardware consume significant amount of energy. So this also is a very good problem which are people are trying to work to reduce the energy. It's a very good research problem how these hardwares can be developed without consuming more amount of energy to make it more immersive. Like these are kind of trade-offs where we try to make the devices to be more real, which can give a more realistic feeling, but may require a significant amount of energy. So addressing this challenge for reducing the energy consumption while providing a immersive real-time immersive experience is also a good research problem. So the impact of this could be battery life of standalone VR devices is often limited, leading to interruptions during long sessions. Then increased energy consumption leads to more frequent recharging, which can disrupt the user experience. So you can see the different impacts of computational demands and energy consumptions, okay, which which poses a challenge for the developers of VR systems. So developers of VR systems must look into these aspects while developing the system for different applications. So some of the applications may require the less energy, less latency. Some of the applications, some of the energy consumption and latencies can be tolerated. So it completely depends on the trade-offs. Completely depends on the what kind of application you try to use the VR systems for development. There are other issues such as ethical issues, privacy and security in immersive environments. Privacy concerns are like we that like I told that sometimes we give our personal data such as body expression, body movement, facial expression, eye movement, gaze estimation. So all these the human data are being collected by the VR systems. There are vast amounts of data are collected, and if they are not protected properly, some intruders which can take our data, or which can take our data from the VR system, it can exploit if they are not properly secured. So these privacy concerns, security risks are there. So this they can be misused by the third parties, especially in sensitive environments like healthcare and education, and having a security risk. So immersive VR environment may expose to users to malicious attacks. So now for the currently there are no such security systems developed to just restrict the malicious attackers to take our data in the VR environment from the VR environment. So always there lies a challenge to develop such security system and to avoid the risk that are associated with the privacy and in the immersive VR environments, which can protect our data from the unauthorized users. So the impact could be like hackers could breach VR platforms to steal potential personal information or disrupt experiences. Cyber security risks are also there, which increase as VR systems become more integrated with cloud-based or multi-user applications. Like suppose in some systems we use cloud-based for applications in the VR. So cloud also there we need to see the how these VR systems are uh, more secure from the cloud-based applications and multi-user applications, because there are many parties there, many uh, parties or many users are interacting together in the VR system, and each user gives its own data and how they can be protected from the malicious attacks. So all these cyber security risks poses a limitation. Cyber security and privacy concerns, these are known as ethical issues, which also poses limitation for developing VR environments. So not only we can develop VR systems directly without concerning these issues, we must ensure that whatever the systems we develop that tries to address these ethical issues. Then accessibility challenges to reach diverse audiences. Okay, like as we know that using VR headsets and the necessary hardware is cannot be afforded by all of us. So this cost of these VR headsets and the hardware required for uh, immersing in ourselves in the VR environment is also puts a limit to use this VR. And physical limitations such as motion restrictions or inability to interact with the traditional controllers may exclude some users. Like some of the having some inability to interact with the traditional controllers, we are not just familiar with some of the controllers or sensors that is required and that is available in the VR headset for making ourselves immersive in the VR environment. So which also restricts the users to use this particular technology. So that's barriers to entry. Okay, so the impact is certain groups, including people with disabilities or those with advanced technology, may find it difficult to access VR content. So it's not always possible for every people to use this technology. So including people with disabilities without advanced technology. So like as I told, to we can have develop a, like for India, if I say, we can develop our own sign language system and try to recognize those gestures and use this for disabled peoples to communicate effectively with the advanced technology, and which is not possible for them to access this VR content directly without this gesture. Then inadequate accessibility features also could prevent VR from becoming a universally inclusive platforms. So all these challenges known as accessibility challenges, which puts a restriction for all diverse audiences to use this technology, VR technology. Then AI driven generative environments in VR. So like we can, this is another technology of computer vision and AI. We can say that we can create a AI driven generative environments in VR. Like AI driven generative design uses algorithms to create dynamic, ever-changing environments within VR. So these environments can be adjusted based on the user interaction, preferences, or even external factors like time of day or weather. So this particular example I have given is somewhat in the beginning of the slide. That what I mean to say this: we can have a generative environment which can be developed by algorithm written by us, and to make it adjust for the user interaction. Preferences means you can generate a VR system based on our preferences, like, and which can take the factors like time of the day or weather. The impact could be personalized and adaptive experience. We can personalize this experience and adapt it as per our requirement with VR environments that responds to user actions and change accordingly. So if it is a generative in nature, we can make it adaptive, and we can make our VR environment change to the change in the environments, and we can generate complex worlds in real time, creating rich, detailed experiences without needing pre-built assets. Like what it says, using these AI-driven generative environments, we can generate a complex and real-time rich environment, which is an environment which is very personal to us, without using the pre-built assets. Like the whatever the tools that I have shown in the previous slides, those are primarily being used for different applications. Like without using these pre-built assets, we can also use AI to generate our own VR environment, where the algorithm will be written by us, and this algorithm will completely depends on with our own preferences, and it can also adapt with our requirement, and can change according to our need. So examples, like one of the there are different AI driven generative environment also been created. One is the AI dungeon, which uses AI to generate interactive narratives that adapt to player input, and procedural content generation. In gaming also, AI has been used to
Reclaim
create
insurance, I shall
endless,
submit later.
endless unique landscapes and missions within VR environments. So with this, we can have some expectation of this VR in future, the future possibilities with computer vision in VR. Okay, so trends to watch: we can have advanced gesture recognition for full body tracking. We can integrate AR and VR for seamless mixed reality. So AR is nothing but about integrating or augmenting a real scene on a virtual environment. Like VR, we have only the virtual environment. So in AR, what we do, we augment a real scene in the virtual environment. So we can integrate AR and VR for mixed reality. When AR is combined with VR, we call that as a mixed reality. And VR and computer vision also have a very good scope for mixed reality. And like AI, there are so many LLMs, large language models, and generative AI models are now present, has been developed by many researchers. Those AI driven mechanisms can be also be used for creating a hyper realistic VR. So the potential impacts would be it will give a fully immersive virtual worlds with natural interactions, and expansion of VR applications across the industry. So there are many future possibilities with computer vision in VR. Though, so the main essence behind all these future aspects is developing a very good algorithm of computer vision for different applications which can combine with VR. So the convergence of AR, VR, and XR, the extended reality, we can call that as extended reality. They are converging to create hybrid immersive experience environments. XR is an umbrella term that encompasses both AR and VR, as well as other immersive technologies. Like as I told, AR augments the real world with digital overlays, typically through smartphones or AR glasses. VR creates a fully immersive virtual environment. XR combines both AR and VR to create a seamless interactive space that bridges the digital and physical worlds. So the future trends, we are trying to mix up all these augmented reality, virtual reality, and try to create a mixed reality. How we call that as extended reality, using this computer vision tools and techniques, and along with the AR, VR hardware and softwares. So this is all about from my side. Uh, so the summary of this particular talk was to is to how we can use computer vision tools and techniques. So the but how if I say in terms of research point of view, so the main theme behind all these techniques are to develop a good computer vision algorithm, good machine learning, deep learning algorithm, and all the using these AR VR tools already available. And there are also research going on in the direction of how to create good hardware with less energy consumption, how it will feel good to the particular human user. Human user should not be tired enough by using these hardwares, and should be able to use this open source software very easily, and with less within a very simple system. I can also should be able to use the create a VR using very small edge devices, low power devices. So all the researches are going on. One direction is computer vision. Vision algorithms are being developed. Hardware for softwares are being developed for VR. Then integration. So the integration is not an issue. The issue lies with the development of hardware and software for VR and development of vision algorithms, which always are the key issues in integrating CV with VR. Thank you all. So now it's open to all of you to have questions which you like to answer those questions. Thank you all for listening to me.
Thank you, Professor. Participants, do you have any questions or any doubt need to be clarified? You can raise your queries. If you'd like to interact with the professor with any questions.
So basically, we work in the computer vision development of computer vision algorithms. Okay, so presently we have started working on developing some of the algorithms which can be integrated in the existing tools of using VR and AR. We didn't do much works on in AR VR environment. We have done a lot of good work in computer vision, which we are now trying to use in the AR and VR, which is not a big task. The always the research focuses on how to generate and how to develop a good CV algorithm, which can be integrated without any issue. And because this development of hardware for AR VR, just a minute, hello. So we try to work on this, and it's open. It's a very open research problem. As I told, there are various issues and challenges that can be addressed, and many research issues are there. Many open problems are there with all of us to develop a good vision algorithm which can be interacted or combined or integrated seamlessly in the VR environment. Thank you.
Thank you, Professor. There's a question
Yes.
in the chat box. How does computer vision enable hand and body gesture recognition in VR?
I told no, so there are
Yes.
like we have the ML and DL algorithms for gesture recognition. Once these algorithms are ready, the tools like Unity and real-time engine are already there for developing the VR environment. So which can be directly deployed for real-time application. So without any issue. So, but the thing lies in the way that you develop your algorithm is very important. So the latency issues, energy issues, all these has to be synchronized with the VR tools already available. Okay, if you are able to synchronize with that, then you can easily develop or integrate the developed algorithms for any recognition, either body recognition, just pose estimation, gesture recognition, facial expression, all these algorithms can be used. So initially for all these tasks, we should go for the already developed tool by the Google engine, already like MediaPipe and Teachable Machines. So they are being created to for basically for AR and VR. We initially to start with, we can use those for integrating in the VR environment. Then we can think of developing our own algorithms.
Okay, Professor. Thank you. Thank you, Professor.
Okay.
I take this opportunity to record our sincere, heartfelt gratitude to our expert, Dr. Ratnakar Dash, Professor, who has shared this insightful information, specifically connecting the computer vision technology with VR. He has briefed out the possibilities, ethical issues, challenges, and also the future prospects of computer vision towards virtual reality, augmented reality, mixed reality, all immersive technologies. And it is quite interesting to listen this session to understand the technology specifically on computer vision, as he highlighted the gesture recognition, which is the base for the virtual reality or any immersive technology. So once again, on behalf of the organizing committee, I take this opportunity to thank the professor. Thank you once again, Professor, for sharing